So, as we say in the part one of the study of mean value theorem, so we want to discuss the mean value theorem. So, you will recall in the first part, we talk about the Rose theorem, which is a concept that we'll be using to derive what we know as the mean value theorem. So, let's just now talk about the mean value theorem. So this says let f of x a single valid function which has the following hypothesis. Number one, okay, is that f of x is continuous in the interval or in the closed interval AB. So f of x is differentiable in the open interval AB, just like we have in the uh, Rose theorem. Okay, the same assumption for the first and the second. Okay, but for the case of the mean value theorem, when these two conditions holds, okay, and that the f of a and f of b are not the same, we recall that in the third condition of the Rose theorem, f of a and f of b are the same. Okay, but for the case of the mean value theorem, they are not the same. Okay, so we do not need to state that. Okay, but anytime these two conditions holds, the mean value theorem says that then there is a number C which is in between A and B such that f prime of C is equal to f of B minus f of A over B minus A. Okay, so f prime of C, of course, here it will be not equal to 0. The reason is that f of B and f of A are not the same. If they are not the same, it means the slope or the mean value here, okay, will be non-zero. Okay, it's non-zero. Okay, if it's non-zero, it means it can be negative if the slope is decreasing, and it can be positive if it's increasing. Okay, so this is what the mean value theorem says. Okay, so let's quickly look at the proof of this mean value theorem. Okay, the mean value. This is the mean value. Okay, so and the point C here is the point that is prescribed by the mean value. Okay, so let's quickly look at the proof of this theorem. So, in order to understand perfectly the proof of this theorem, okay, let us describe what we have just said here on the graph. Okay, suppose we have a curve of this form, and this curve is defined on the interval AB. Okay, here we have f of a, and here we have f of b. As you can see, these are not the same. They are not the same because this line is not the same thing as uh, the horizontal line. Okay, as you can see here, they are not the same. Okay, since they are not the same, f of a and f of b are not the same. Assuming they are the same, okay, the difference between f of a and f of b should be a parallel line to the x-axis. Okay, so this curve is a function of x. Okay, so what the mean value theorem is now saying is that there will be a line that is parallel to this. Such a line will be touching this curve. Okay, a line that is parallel to this will be a curve such as this. Okay, and at the point, this curve is this line this line is now the mean that we are talking about here, which is not equal to 0. It's not equal to 0 because it is slopey. Okay, and the point at which this is happening is the point C, which is the prescribed point. Okay, so and here is the mean value, which is not equal to 0. Okay, so this is just an example of what is happening there. Okay, so let us now use this graph to prove the mean value formula or the mean value theory. Okay, so let's say the proof now. Okay, as we have it in the theorem, we say suppose f of x. So for the proof, we say suppose f of x is defined in the interval a comma b. That is the closed interval as we have it in the theorem. Okay, so when we observe there is a line, okay, joining the point AB, okay, these 2 points, where this point A has the coordinate, the point A has the coordinate a comma b, a comma f of a, y b has the coordinate b comma f of b. Okay, so the line or the equation of the line joining the point AB, okay, will be given as okay, the equation of the line joining these 2 points. Okay, this is the 2-point equation 4. Okay, and it will be given by y minus f of a equal to you see the slope of this line. Okay, you know the slope of this line will be the difference of this and this all over b minus a. Okay, multiplied by this. Okay, so you will recall that equation of a straight line at one point is y minus f of a equal to the slope, okay, multiplied by x minus a. Okay, so since we already know the slope, okay, for this line, okay, so we quickly substitute that. Okay, so from here, this equation implies that if we transfer this time to this place, it becomes this. Okay, so let's call this a particular equation. Okay, and also let's h, this h of x is a particular equation or a function represents the difference between this f of x and the entire y. Okay, so this will be f of x minus the entire thing here, and that will be this minus f of b minus f of a all over b minus a. Everything multiplied by this. Okay, so if we differentiate this function with respect to the argument x, okay, this will reduce to this will reduce to h prime of x equal to f prime of x. Of course, f of a here is a constant, that will be 0. If we open the bracket here and we differentiate this with respect to x, this x here will be 1, while this will be 0. Okay, so 1 multiplied by this will be minus f of b minus f of a. Okay, we are giving this a bigger bracket so that because of the negative there, okay, and this will be over b minus a. Okay, so now according to the Ross theorem, can I apply the Ross theorem to this? So we also observe that this function h of s is defined in the interval a comma b, okay, and by the Ross theorem, we can apply Ross theorem to this. You can see there is a point C which is in between a comma b, okay, so that we can evaluate this function at that point, and this will be equal to this and this minus f of b, and we give this a regular bracket f of b over minus c. Okay, so according to the Ross theorem, this slope, okay, is 0 at that point. Okay, so since this is 0, okay, this means the entire this is equal to 0, and therefore f prime of c is equal to b minus a b of b minus f of a by b minus a. So this is how we get the mean value formula as this. Okay, so all the concepts here are proved using the graph above. Okay, and what we have done is not far-fetched. Okay, we deduce and from equation of a straight line, we deduce the value for y as this, and then of course we have a curve which is known as f of x. Okay, what we do is that we find the difference of that f of x and this y, okay, to give this equation. Okay, so when we do that, we now differentiate this function with respect to the argument x, okay, and we apply the Ross theorem to get that, to get the mean value formula. Okay, so that is that. So we can now look at some examples of this mean value theorem. How do we apply this mean value theorem to solve real problems in calculus? Okay, so find the mean value and its prescribed point. Given that f of x is equal to x squared minus 3x plus 1 in the interval 0, 2. So let's see how we solve this. The formula we have there is the formula for the mean value. So in order to get that, we say that already we have been given this to be this, and this is we'll see from the formula we know what f of a is. F of a is similar to f of 0, okay, because this point is equivalent to a comma b, okay. So the point 0 here implies a, yb is 2, okay. So here we have this to be 1, because this will be 0 minus 0, and that will be 1. And again, f of b means f of 2, and it will be minus 1. Okay, so therefore, the mean value at the point C, which is same thing as f of 2 minus f of 0 over 2 minus 0, this will be equal to minus 1 over 2. And this is a minus 2 over 2, and this is a negative 1. Okay, so here the main value here is negative 1. Okay, showing that the graph is decreasing. Okay, so but the question says we should find the prescribed point, that is the point C where the curve is turning. Okay, so now say at the point C, which is in between 0 and 2. Okay, so of course the function here, which is this, will be f prime of C equal to C, okay, minus 3C. Okay, what we have done here is to find the derivative of this function, then substitute C there, and of course this will be this. Okay, so since we have the mean value to be negative 1, okay, so the mean value here, that's f prime of C, okay, is negative 1. Okay, and we are able to get the slope from here. Okay, when we find the derivative of this, then substitute C in the derivative, so to get this. Okay, so this implies that 2C will be equal to minus 1 plus 3. Okay, and this implies that this will be 2 from here, and 2C equal to 2, and this implies that this C will equal to 1. And of course, we'll see that this one is a member of this interval. Okay, so the point 1 is a member of this interval. So here we have the mean value to be negative 1, while the prescribed point here is 1. Okay, so that is that on the example. Okay, so there are other examples that one can is applicable to the following. Number 1, the function f of s equal to x minus 5x plus 4 with s minus 3 on the interval 1 to 5. Okay, and secondly, I want to see whether f of x equal to 2x squared minus 7x plus 1 on 0, or negative 1 to 4. Okay, so I want to test if the mean value is applicable to to these two functions. Okay, so furthermore, if yes, okay, that is if it is possible that the mean value theorem is applicable to these two. Okay, and what we check? We check whether this function is continuous and differentiable on the closed and open interval of this form. Simply for this, if it's applicable, I mean, if that conditions are valid, okay, then we can now see, then we can now further to find the prescribed point. In each case, we find the prescribed point. Okay, so that is that. Okay, so but before we end the class, let's quickly make a remark here. Okay, well, the remark is however obvious from the beginning, but let's have it. So before now, we have said that the mean value theorem is given by this formula. Okay, so this will refer to as the mean value. Okay, and according to the Ross theorem, it says if the function is continuous, differentiable on an open interval, and then if these two terms are the same, okay, according to the Ross theorem, it says this slope will be equal to 0. Okay, so this is obvious from here. Okay, so we see that this term here, or this mean value, will be 0 if f of a is the same thing as f of b. Okay, so this concept alone, okay, is discussed by Rho. Okay, under the Ross theorem. This is what the Ross theorem is talking about. That if these two terms are the same, okay, this is what we get. Okay, if they are not the same, okay, we'll call it the mean value. Okay, so here is just a simple remark. Okay, so there are several functions or behavior where one can find either the mean value or apply the Ross theorem to solve.